For example, you will learn how to use the web browser's built-in developer tools and code using industry-standard software known as an integrated development environment, or IDE. Professionals use IDEs to write code more efficiently. In Module 2, you will begin your coding journey with an introduction to HTML5 and CSS. You will learn the basics of each of these languages and how they complement each other to lay out and style elements on a web page. This includes text, images, and multimedia elements like video. Additionally, to make sure that your web page is accessible to everyone, you will learn how to code for web accessibility. In Module 3, you will learn how developers use frameworks and libraries. This module will focus on responsive design. You will learn how to implement the Bootstrap library so that web pages can offer a great browsing experience no matter what type of device is used. You will also learn about user interface or UI design and how to work with common UI components and position them using the flexible Bootstrap grid. Next, you'll be introduced to React, a free and open source JavaScript library that developers use to build user interfaces based on UI components. And you will then learn about the difference between static and dynamic content and the benefits of using single-page applications. And speaking of content, in Module 4, you will have an opportunity to put your new skills into practice by editing your very own biographical web page. In summary, this course provides you with an introduction to web development. It is part of a program of courses that leads you towards a career in software development. There are many videos in your course that will gradually guide you toward that goal. Watch, pause, rewind, and re-watch the videos until you are confident in your skills. Then, consolidate your knowledge by consulting the course readings and put your skills into practice during the course exercises. Along the way, you'll encounter several knowledge quizzes where you can self-check your progress. You're not alone in considering a career as a web developer, and the course discussion prompts enable you to connect with your classmates. It's a great way to share knowledge, discuss difficulties, and make new friends. To be successful in the course, you should try to develop a schedule for your learning regime. Ideally, commit yourself to a regular time slot and duration for your study. You've probably encountered many new technical words and terminology in this video. Don't worry if you don't fully understand all these terms right now. Everything will become clearer as you progress through the course. When you eat at a restaurant, there are often many cooks preparing different parts of your meal. Similarly, for the websites and applications you use every day, many roles are involved in delivering these projects to users. If you were to look up a list of high-paying IT jobs, web developer roles would certainly feature prominently, and with good reason. The digital world that we all live in would not be possible without developers creating, architecting, and maintaining the technology that we use every day on our devices. But it can be confusing for aspiring developers to understand some of the terminology associated with web development. Finding the right area for you, terminology associated with web development. Finding the right area for you will depend on a greater understanding of web developers' roles, responsibilities, and technologies. For example, suppose you are a visual person. In that case, you might want to design a stunning website that offers an excellent experience for its end users. Or, if you're more analytical, you might be interested in working with the technologies that power a high-performing e-commerce site. Likewise, if your interest is mobile devices, your passion may lie in creating the next big social media app. While job roles and titles may vary, web developer roles are usually split into front-end, back-end, and full stack. In this video, you will learn about each of these, their differences, and the skills required to gain a job in these areas. A front-end developer is someone that works on all parts of a website or web app that users will interact with. This can be anything from the style, colors, buttons, menus, or user interactions as they click, swipe, and interact with the site. The skills of a front-end developer can vary, but they will always focus on three leading technologies: HTML, CSS, and JavaScript. For example, suppose you are a front-end developer assigned the task of adding a newsletter sign-up option to the homepage of a website. In this case, you would use HTML to build the display elements, such as the input area for the user to type their email address and then the button to click to send it. You can then use CSS to position, color, and style these elements on the page. And finally, you can use JavaScript to process the activity when the user clicks the button. This could be something like checking the email address is valid and then sending that email address to the website for storage under newsletter members. While HTML and CSS skills are essential, the most critical skill is usually JavaScript. It is the powerhouse of front-end technology. This is mainly because of its versatility and the fact that it is paired with powerful libraries and frameworks such as React by Meta. These can be used to build rich user interface-driven enterprise websites and web apps that are fast, secure, and highly scalable. The salary of front-end developers are competitive and can vary based on experience. Generally, front-end developer roles will be available for junior, intermediate, and senior level professionals. As an aspiring developer, junior, intermediate, and senior level professionals. As an aspiring developer, this is a great area to get started in. Entry into the job market for a junior position is possible with some fundamental demonstrations of core concepts and skills and an eye-catching sample portfolio. A back-end developer works on the parts of a website or web app that the end users don't see. These activities occur behind the scenes, particularly on the web server, in the database, or in constructing the architecture. Back-end developers are responsible for creating and maintaining functionality when users request information or when the website needs to communicate to another part of the web architecture for processing. For example, performing an account login or completing an online purchase using a credit card. A back-end developer will facilitate the interaction of the website and the content stored in a database. As a result, back-end development requires different languages, skills, and tools. While these can vary, they generally consist of knowledge relating to back-end programming language, database management systems, APIs, and web servers. Salaries are similar to front-end developers and depend on experience. Still, the salary may be higher in some instances, especially for entry and senior level positions. This is because getting started with back-end technologies requires more setup, configuration, resources, and general IT structural knowledge. This is in contrast to the front end, where you can start learning some elements using only a web browser. The road to back-end development is generally long, as you must have a proficient understanding of the needs of front-end technologies. This can include things like the inner workings of the internet, networks, and servers. It's pretty common for aspiring developers to first start with the front end and then move to the back end once they have acquired specialized knowledge. A full-stack developer is someone equally comfortable working with front-end and back-end technologies. Full-stack developers have skills and knowledge in all areas of the web development project cycle. For example, they have relevant expertise in the planning, architecture, design, development, deployment, and maintenance of the website or web app. Development, deployment, and maintenance of the website or web app. Full-stack developer positions are generally at a more senior level. It can take some time to gain the knowledge, professional experience, and skills to become a full-stack developer. As a result, roles in this area are in high demand and are some of the best paid jobs in the IT industry.
I think where front-end development's different is you have to work with designers, you've got to work with product managers. It's fundamentally very collaborative. It's got like the right brain, algorithmic thinking and how to make things performant and work, and then it's got the left brain, like how do you make things usable and enjoyable to use. Well, I sort of found my way into front-end engineering, and now it's like I couldn't imagine leaving it. Hello, I'm Benedict Hobart. People call me Benny. I'm a software engineer at Meta. I think a lot of people that get into front-end engineering, they don't really think about front-end engineering as an engineering problem. You're building stuff, you're solving a problem. When what you're doing is building products for people and you're helping people solve their own problems. So there's a lot of collaboration that comes with that, working with designers, working with PMs. You're not some programmer slouched over a desk, typing away all day. It's a highly collaborative environment you're stepping into. I started when I was fairly young with building a fan website for a game called EverQuest. So I first started making websites around that time, but I never really considered it as a career path. I actually left building websites and came back to it later in university. I think where I really actually started treating it like a career was in my second year of university. I had a cool cousin who was a programmer, and he was like, you should do this subject. What hooked me initially was that I was
Portfolio.
Hello and welcome. Did you ever find yourself searching for something online? How long did it take to get a response from your search? You search for something and you get a response back in no time. That's really something, isn't it? But did you ever think about how it all happens? In this video, I will guide you through the basics of how the internet works. Let's start at the beginning. You open your favorite app on your device and you're instantly connected to the world. This is all made possible because two devices connect and communicate via a wired or wireless connection, forming something called a network. You can connect multiple devices to this network, but this becomes very complicated very quickly, as each device needs to connect to every other device to communicate effectively. This problem is solved by something called a network switch that connects multiple devices and allows them to communicate with each other. The network switch can connect to other network switches, and now two networks can connect. These network switches then connect to more network switches until you have something called an interconnected network. This interconnected network has another name that you might be familiar with. It's called the Internet. When we use websites or video streaming services on the internet, these are provided by computers called servers. Our devices are called clients. This is known as the client-server model. The internet connects the entire world. Have you ever had a video call with someone on another continent? That video data traveled through large undersea cables connecting the world's networks, and these cables can transfer huge volumes of data per second. There are a lot more technical details that go into making the internet possible. But this is the main idea. Hopefully, this gave you the big picture of how the internet works. A server is a computer that runs applications and services, ranging from websites to instant messaging. It's called a server because it provides a service to another computer and its user, hardware and software. You also have a client. It's typically stored in something called instant messaging. A server is a computer that runs applications and services, ranging from websites to instant messaging. It's called a server because it provides a service to another computer and its user, also known as the client. It's typically stored in something called a data center with hundreds or thousands of other servers, all running different services connected to the internet. There are many different systems in data centers to ensure that servers have continuous power, continuous internet connection, and are kept cool 24 hours per day. Did you know that there are data centers located all around the world? Many websites use these to allow you to access your content quickly from the data center nearest to you. The data center servers are built based on the server's purpose. For example, if the server is only to be used for storing images, it might have a lot of hard drive space, whereas a server computing complex calculations might need a fast processor and a lot of memory. This is usually referred to as the server hardware, the physical components of a server. Once the server hardware is installed in the data center, a piece of code can now run. The code that runs on the hardware is commonly known as software. One way I like to remember this is to think of hardware as something you can physically touch and is difficult to change, as you need to physically replace components. Software is soft or easy to change. You just replace the code running on the server. The services a server can run can vary, but in this video, you will learn about a type of server software known as a web server. A web server has many functions, which includes website storage and administration, data storage, security, and managing email. Another primary function is to handle something known as a web request. When you open a browser on your device and type the name of the website, it's the job of the web server to send you back to that website's content. This process is known as the request-response cycle, and you will learn more about it later. Web servers are also designed to respond to thousands of requests from clients per second.
Server is a computer class that runs applications and services ranging from websites to instant messaging. You have just learned about a web server, which is a specific type of server, which of the following statements are true. Actually, all that one. A web server can function as website storage and administration. Web servers can handle thousands of requests per second. Yes, a web server can handle security web doesn't.
In this video, you learned about web servers and how they consist of hardware and software. You also learned that one of the primary roles of a web server is to respond to web requests from the client. You may have heard the terms web pages and websites, but what's the difference? A web page is a document that displays images, text, videos, and other content in the web browser. A website is a collection of web pages that link together. You've likely visited many websites this week. In fact, you're watching a video on one right now. Let's explore an example where you visit your favorite encyclopedia website. When you arrive at the homepage, it contains many links to different articles. Clicking on one of those links brings you to a new web page article, and that article links to even more articles on other web pages. If all these web pages have a similar address in the web browser's address bar, it can be safe to assume that they belong to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, have to link to the same website. However, the links on the page do not all have to link to the same website. They can also link to other websites. For example, when you visit your favorite search engine and search for a phrase, the search results are a list of links to other websites. Did you know that as I'm talking to you, thousands of websites are being launched to the internet? Every day, hundreds of thousands of websites are launched. To put things into perspective, the Great Pyramid of Giza has 2.3 million blocks of stone. So think about it. In 1 week, there are as many new web pages as stones in the Great Pyramid. With current internet speeds, it would take 3 million years to download all the web pages on the internet. And all of these billions of varied web pages rely on the same core technologies. Most people interact with websites in some form daily, but few know how a web page actually works. I mean, what's it made up of? And just how does that web page get from the web server to what you see on your screen or device? Well, let's explore that now. In its most basic form, a web page is just a text document. You can open and edit with any text editor. But developers usually use more sophisticated tools for working with web pages. If you want to work with a web page, you need to know about 3 technologies and understand how they interact. They are HTML, CSS, and JavaScript. HTML structures the content you see. CSS controls the colors and style, and JavaScript is responsible for the user interaction. As a web developer, you will work with these technologies every day and understand how they work together. I always like to imagine it like this. Think of a shop. HTML is the actual building, the structure. CSS is the interior decoration and landscaping outside, and JavaScript is just like the business, the services offered, and the people coming in and out. Let me give you a brief overview of each of these technologies now. HTML stands for Hypertext Markup Language. It works by using something called markup tags. These tags describe the content that is displayed in the browser window. This content can be things like headings, paragraphs, images, and even multimedia elements such as audio and video. The way HTML describes the content is known as markup. CSS is short for cascading style sheets and adds visual enhancements like colors and layout to the web page. This is commonly known as styling. It works by enhancing the HTML elements and telling them how to display. Have you ever noticed a friend change the color or style of their hair? Well, your friend's hair is like the HTML, and the color and style is CSS. The last technology is JavaScript, which is a programming language built into the browser. JavaScript provides web developers with tools for interactivity, data processing, control, and action. Have you ever tried to log into a website only to be told that the information you provided was incorrect? Or browsed your favorite video streaming site and seen content update in real time? Well, that's JavaScript in action. JavaScript is the powerhouse of a web page. It has the ability to manipulate the content that you see on the screen as you interact with it. In fact, without JavaScript, websites would be kind of boring and very limited in terms of what you can do. Okay, you now know about the essential technologies a web page contains, but how exactly does this code get translated to display the content that you see on your screen? When a copy of that web page is sent from the web server to your browser, each line of code is processed in sequential order from first to last. As each line is interpreted, the browser creates the building blocks, which is the visual representation you see on the screen. This creation process is known as page rendering. The response from the web server must be a complete web page in order to fulfill the request to show the page in the browser. You will learn more about page rendering from the additional reading at the end of this lesson. And there you have it. You now have joined the exclusive group of developers who know how a web page works. You learned about the technologies that make up a web page and how they interact with each other. You also learned that the page is rendered by the web browser to display what the end user sees on the screen. In the time since you started watching this video, another few thousand websites launched. Every one of them is another example of modern web developers building and adding to the ever-growing internet. Are you ready to become one of them? You use a web browser every day on your devices, and you probably have one open right now watching this video. But do you really know how they work? In this video, you will learn what a web browser is and how it receives and displays content. Let's get started. A web browser, or browser for short, is a software application that you use to browse the World Wide Web. It works by sending a request to a web server and then receives a response containing the content that is to be displayed on the screen of your device. Once the browser is open on your device, there is the address bar where you input the address of the website that you want to visit. The address is commonly known as the Uniform Resource Locator, or URL for short. The URL contains the protocol, or the HTTP, the domain name, usually the name of the website, and the file path, or the path to the page that is displayed. When you make a request using this URL, the browser and server communicate using a protocol known as the Hypertext Transfer Protocol, or HTTP. Once the web browser receives the content, it displays it on the screen of your device. This exchange of information is made possible by something known as the request-response cycle. Now, let me demonstrate this using an example many of us are familiar with, searching the web. First, you open a web browser, which is a software application. Next, you type the name of your favorite search engine. The name you type contains something called a domain name. Then, when you press enter, the web browser sends a request across a network and connects to another computer on the internet called a web server. The web server is a special type of computer that allows other computers to make requests for data. The web server responds by sending a web page back to the browser. Once the browser receives all the response information, the search engine web page is made visible. The web page is a coded document that is rendered by the browser and then presented visually to you, the end user. Now that the search engine web page is loaded in the browser, you interact with that page to search for what you want to find. For example, type restaurants near me in the search bar and press the search button. Once again, the browser prepares and sends a request to the same search engine web server. This time, the request contains the added instructions to search for the phrase restaurants near me. The search engine web server processes the request by taking the keyword and using it to find the requested data. This data is stored in something called a database, which is connected to the web server. The web server then picks up that data and sends it back to the browser. When the web browser receives the full response from the web server, it again renders a visible web page with links to some restaurants, a map showing nearby locations, and more related information such as reviews, lists, and even reservations. Success, and all made possible by computers having a conversation. You have now gained an insight into how the request-response cycle works. And this web request cycle is very similar for a number of other activities we do online, be it chatting with friends, watching our favorite movie, or sharing files with our work colleagues. That is just a brief summary of how the internet works. The next time you search for something online, think of all the steps and data that gets exchanged to complete your request. Okay, so by now you know that websites and files are stored on web servers located in data centers. But what if you wanted to create your own website? Do you really need your own data center with specialized hardware and software? Thankfully, the answer is no. And develop specialized hardware. What if you wanted to create your own website? Do you really need your own data center with specialized hardware and software? Thankfully, the answer is no. And developers can launch websites to the internet using something known as web hosting. Web hosting is a service where you place your website and files on the hosting company's web server. Okay, so by now you know that websites and files are stored on web servers located in data centers. But what if you wanted to create your own website? Do you really need your own data center with specialized hardware and software? Thankfully, the answer is no. And developers can launch websites to the internet using something known as web hosting. Web hosting is a service where you place your website and files on the hosting company's web server. You're essentially renting this space in return for stable and secure storage. And you don't need to be a company to use a web host. Individuals can rent space too. In this video, you will learn about the different types of web hosting services that you can use for your websites and web applications. First, let me share with you some of the different hosting options available. These can include shared hosting, virtual private hosting, dedicated hosting, and cloud hosting. Let's explore each of these hosting types in a little more detail now. The cheapest form of web hosting is known as shared hosting. You pay for a location on a web server containing many web hosting accounts with shared hosting. This means that you also share the containing many form of web hosting is known as shared hosting. You pay for a location on a web server containing many web hosting accounts with shared hosting. This means that you also share the server's processing power, memory, and bandwidth with other websites that might slow your performance. This option is best for a small website with a small number of visitors. Many developers also use this as a low-cost sandbox environment to practice deploying or hosting their personal websites. Some companies offer free shared hosting, but with limitations, and often have advertisements embedded in the web pages. Sites with more considerable demands use virtual private servers, or VPS. A VPS is a virtual server with dedicated CPU, memory, and bandwidth resources. It will be running on a hardware server with other VPS instances, but as the resources are fixed per VPS instance, your website is unlikely to be impacted by the performance of other VPS instances. A VPS instance will be more expensive than shared hosting. The next option up is to use dedicated hosting. This will be a hardware server that is dedicated to you only. All hardware CPU, memory, and bandwidth resources are yours to use. Generally, this option is more expensive than a VPS hosting. The last type of web hosting is something you may have heard of. Cloud hosting and the cloud has grown in popularity over the last decade and is often mentioned in various news and services you use. With cloud hosting, your website is run in something called a cloud environment, which spans across multiple physical and virtual servers. If a physical or virtual server fails, your website will run on a different server and stay online. The main advantage of cloud hosting is that you can use as many resources as you need without hardware limitations. However, you pay based on resource use. For example, if you transfer a file from the cloud to a web browser, you'll pay for the bandwidth used for that transfer at a fractional cent cost per megabyte. While this can quickly become more expensive, it allows websites and web applications to scale their costs as popularity grows. This is how many of the major web applications operate. In this video, you learned about web hosting and the different hosting options available to individuals and companies. Soon you will build your very first website. Are you excited to get it hosted so you can share it with the world? For more information on web hosting and services, please see the additional reading at the end of this lesson.
Cloud computing is the on-demand delivery of IT resources via the internet, with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you can access technology services such as computing power, storage, and databases on an as-needed basis from a cloud provider like Amazon Web Services. Organizations of every type, size, and industry are using the cloud for a wide variety of use cases, such as data backup, disaster recovery, email, virtual desktops, software development and testing, big data analytics, and customer-facing web applications. For example, healthcare companies are using the cloud to develop more personalized treatments for patients. Financial services companies are using the cloud to power real-time fraud detection and prevention. And video game makers are using the cloud to deliver online games to millions of players around the world. With cloud computing, your business can become more agile, reduce costs, instantly scale, and deploy globally in minutes. Cloud computing gives you instant access to a broad range of technologies so you can innovate faster and build nearly anything you can imagine. From infrastructure services such as compute, storage, and databases, to Internet of Things, machine learning, data analytics, and much more. You can deploy technology services in a matter of minutes and get from idea to implementation several orders of magnitude.
Email is a common communication method that we all know about. But before it existed, the alternative was to send mail to one another through the postal system. There is a surprising parallel between the postal system and how the computer sends and receives data across the internet every day. Let's compare how they both work. Email is a common communication method that we all know about. But before it existed, the alternative was to send mail to one another through the postal system. There is a surprising parallel between the postal system and how the computer sends and receives data across the internet every day. Let's compare how they both work. Data sent across the internet is quite an important part of our everyday lives, and it wouldn't be possible without Internet Protocol addresses, or IP addresses. A useful way to think of IP addresses is that they function much like addresses in a postal system that make it possible for packets of information to be delivered to you. And, like with the postal system, things can go wrong. But let's first go over how things work before we think about how they can go wrong. In this video, you will learn what IP addresses are and explore how computers send data across the internet. You previously learned how computers connect to each other to form networks and how these networks connect to each other to form the internet. When you send data between computers across the internet, a common way of understanding this is that the computers are the destinations that request and receive the data, and the networks are the routes that the data travels across. What makes that possible is the Internet Protocol. Version 4 and version 6 are currently the two most widely used standards of Internet Protocol. Think of that old-fashioned postal system again. When you send a letter to a friend, you need their address, otherwise they won't receive your letter. Computers work in a similar way. Every computer on a network is assigned an IP address. In Protocol version 4, an IP address contains 4 octets separated by periods or dots. For example, 192.0.2.235. In Protocol version 6, an IP address contains 8 groups of hexadecimal digits. In Protocol version 192, dots separated by periods or dots. For example, contains 4 IP address. In Protocol version 4, an IP address on a network is assigned an IP address. In Protocol version 4, an IP address contains 4 octets separated by periods or dots. For example, 192.0.2.235. In Protocol version 6, an IP address contains 8 groups of hexadecimal digits separated by a colon. When you send data across a network, you send the data as a series of messages called IP packets, also known as datagrams. At a high level, IP packets, also known as datagrams, as a series separated by a colon. When you send data across a network, you send the data as a series of messages called IP packets, also known as datagrams. At a high level, IP packets contain a header and a payload, which is the data. Think of that old-fashioned postal system again. When you send a letter, you not only include the recipient's address, but also your own address, in case a return location is needed. IP packets are the same. They include the destination IP address and source IP address. These addresses are in the header along with some additional information to help deliver the packet. And the payload contains the data of the packet and some of the other protocols, which we'll cover in a moment. Earlier, I mentioned that things can go wrong with a postal system. When sending multiple letters to a friend, it's possible they may arrive out of order. It's possible that a package will get damaged, or if you're really unlucky, a letter could get lost. These issues can happen to IP packets too. They can arrive out of order, become damaged or corrupted during transit, or be dropped or lost during transit. To solve these problems, the payload part of the packets contains other protocols too. You can think of them as another message inside the payload of the IP packet. The two most common protocols are the Transmission Control Protocol, referred to as TCP, and the User Datagram Protocol, also known as UDP. TCP can solve all 3 of the previously mentioned issues, but at the cost of a small delay when sending the data. This protocol is used for sending the data that must arrive correctly and in order, such as a text or image files. UDP solves the corrupt packet issue, but packets can still arrive out of order or not arrive at all. This protocol is used for sending data that can tolerate some data loss, such as voice calls or live video streaming. Both of these protocols contain payloads that contain further protocols inside of them. And there you have it. The internet uses internet protocols, much like an old-fashioned postal system.
Is the following statement true or false? The payload part of AP packets for multiple protocols to make sure that information arrives expected. 2 of these are transmission protocol and user diagram protocol. UDP is used to send data that must arrive correctly and in order. No, fast. TCP is used for that data that must arrive correctly and in order. This is because TCP can deal with the data package arriving out of order, become damaged or occurred, corrupted, or dropped or lost about at the cost of small delay.
These protocols can help to make sure that data arrives in order, does not become corrupted or lost or dropped during transit. Now you're able to explain how IP addresses work and how computers send data across the internet.
An internet protocol. What is the internet protocol? IP, yes. The internet protocol IP is protocol or set of rules for routing and addressing packets of data so that they can travel across networks and arrive at the correct destination. Data traversing the internet is divided into smaller pieces called packets. IP information is attached to each packet, and this information helps to send packets to the right place. Every device or domain that connects to the internet is assigned an IP address, and as packets are directed to the IP address attached to them, data arrives where it is needed. How does IP routing work? The internet is made of interconnected large networks that are each responsible for containing blocks of IP addresses. These large networks are known as autonomous systems. A variety of routing protocols, including BGP, help route packets across based on their destination IP addresses. Routers have routing tables that include which is application, transport, internet. Transport, mean indicating the way data is sending and received. The TCP header is included in the data portion of each packet. that uses TCP/IP before transmission data. TCP opens a connection with the reception. Yes, TCP ensures that a package arrives in order once transmission begins. Via TCP, the receiver will acknowledge receiving its packet that arrives. Missing package will be sent again if receives. Cái từ này đọc sao ta?
Receipt.
Received is not acknowledged. TCP reliability, not speed, because TCP has to make sure all packets arrive in order. Loading data via TCP/IP can take longer if some packets are missing. TCP and IP were originally designed to be used together, and these are often referred to as the TCP/IP suite. However, other transport protocols can be used with IP. What is UDP/IP? The User Diagram Protocol, or UDP, is another widely used transport protocol. It is faster than protocol, but it is also less reliable. UDP does not make sure all packets are delivered and in order, and it does not establish a connection before beginning or receiving transmission. Là tại sao? Phần này khá hay đấy. I don't need no, I need you now. I don't need more time, I need you now.
Have you ever noticed the lock icon beside the URL in your web browser? This means that HTTPS, the secure version of HTTP, is being used. HTTP is a core operational protocol of the World Wide Web. It is what enables your web browser to communicate with the web server that hosts a website. HTTP is the communication protocol you use whenever you browse the web. HTTP stands for Hypertext Transfer Protocol. It is a protocol used for transferring web resources such as HTML documents, images, styles, and other files. HTTP is a request-response-based protocol. A web browser or client sends an HTTP request to a server, and the web server sends the HTTP response back to the browser. Next, the web server sends the HTTP response back to the browser. Next, let's start exploring the makeup of an HTTP request. An HTTP request consists of a method, path, version, and headers. The HTTP method describes the type of action that the client wants to perform. The primary or the most commonly used HTTP methods are get, post, put, and delete. The get method is used to retrieve information from the given server. The post request is used to send data to the server. The put method updates whatever currently exists on the web server with something else, and the delete method removes the resource. The path is the representation of where the resource is stored on the web server. For example, if you wanted to request an image from a page in a website, then the URL in the address bar would need to contain the full path to that particular file on the web server, such as example.com/images/image.jpg. There are multiple versions of the HTTP protocol. I won't explore these right now, but I want you to be aware that versions 1.1 and 2.0 are the most used. Finally, there are the headers. Headers contain additional information about the request and the client that is making the request. And for certain request methods, the request will also contain a body of content that the client is sending. Now, let's cover some details about the makeup of an HTTP response. HTTP responses follow a format similar to the request format. Following the header, the response will optionally contain a message body consisting of the response content, such as the HTML document, the image file, and so forth. HTTP status codes contained within the header indicate if the HTTP request successfully completed. The code values are in the range of 100 to 599 and are grouped by purpose. The status message is a text representation of the status code. During your web browsing, have you ever encountered pages that display 404 error not found or 500 errors, server is not responding? These are HTTP status codes. I want to briefly explain to you about the status codes and their grouping. There are 5 groups of status codes. They are grouped by the first digit of the error number. Informational is grouped from 100 to 199. Successful responses are grouped from 200 to 299. Redirection message are from 300 to 399. Client error responses range from 400 to 499, and server error responses are from 500 to 599. Information responses are provisional responses sent by the server. These responses are interim, before the actual response. the most common information response is 100 continue, which indicates that the web client should continue the request or ignore the response if the request is already finished. Successful responses indicate that the request was successfully processed by the web server, with the most common success response being 200 OK. You're receiving these responses every day when you receive content successfully from a website. The meaning of OK depends on the HTTP method. If the method is GET, it means that the resource was found and is included in the body of the HTTP response. If it's POST, it means that the resource was successfully transmitted to the web server. And if it's PUT, the resource was successfully transmitted to the web server. Finally, if the method is delete, it means the resource was deleted. Redirection responses indicate to the web client that the requested resource has been moved to a different path. The most common response codes used are 301 moved permanently and 302 found. The difference between the redirection messages 301 and 302 is that 302 indicates a temporary redirection. The resource has been temporarily moved. When web browsers receive these responses, they will automatically submit the request for the resource at the new path. Client error responses indicate that the request contained bad syntax or content and cannot be processed by the web server. The most common codes use data to the web into an account before the request can be processed. 403 is used to indicate that the request was valid, but that the web server is refusing that the use bad data to the web server. 401 is used to indicate that the user must log into an account before the request can be processed. 403 is used to indicate that the request was valid, but that the web server is refusing to process it. This is often used to indicate that a user does not have sufficient permissions to execute an action in a web application. 404 is used to indicate that the request resource was not found on the web server. Server error responses indicate that a failure occurred on the web server while trying to process the request. The most common code used is 500 internal server error, which is a generic error status indicating that the server failed to process the request. Now, have you ever bought something online and needed to enter your credit card information? You wouldn't want someone else to get this information from the HTTP request, right? This is where HTTPS is involved. HTTPS is the secure version of HTTP. It is used for secure communication between two computers so that nobody else can see the information being sent and received. It does this by using something called encryption. We won't cover encryption right now. Like in HTTP, the requests and responses still behave in the same way and have the same content. The big difference is that before the content is sent, it is turned into a secret code. Only the other computer can turn the secret code back into its original content. If someone else was to look at the code, it wouldn't be understandable. You use HTTPS every day. This is the lock icon you see beside the URL in your web browser. Okay, before I finish, I want to leave you with a brief summary of HTTP. Firstly, it is a protocol used by web clients and web servers. It works to transfer web resources such as HTML files and is the foundation of any data exchanges on the web. Also, remember that by using HTTPS, we send the information securely. Requests are sent by the client, usually a web browser, and the server replies with responses, which may be the return of an image or an HTML page. HTTP requests have a syntax that includes method, path, versions, and headers. HTTP responses follow a similar format to the request, and HTTP status codes indicate whether the HTTP request is successfully completed. The status code is a 3-digit number that corresponds with groups representing different types of results. Well, now you know how the HTTP protocol request and response cycle works. You know about its methods and the elements that make up an HTTP request. Good job. The web pages you visit every day are application, and the code in the JavaScript is in applications, so you can offer any content you have seen online. In this video, I will demonstrate 2 examples you can create using these technologies. This is to help you understand how they interact with one another. Don't worry, you won't need to deal with the details of the 3 languages just yet. In the first example, I'm building a web page that displays a digital clock. It shows the hour, minutes, and seconds. The time is updated every second. I will work with 3 files, an HTML, a CSS, and a JavaScript file, and you will explore the purpose of each one of them. To create the clock element, let's first define our HTML code in a file called clock.html. The HTML code has an element that describes the content in hours, minutes, and seconds. If I only use the HTML file, the content would be shown without any style, positioning, or sizing, just simply as a display of 6 zeros representing time in the format of hours, minutes, seconds. To apply styles to the HTML element, the HTML code references a CSS file called styles.css. The web browser retrieves the styles.css file and processes it. The CSS code provides styling for the clock. It tells the browser the position, size, color, background, and font type and size of each element on the screen. With that information, the browser updates the content, and the sequence of zeros and colons now display a digital clock. Finally, we need to ensure the clock updates with the correct time. This is where JavaScript comes in. We retrieve clock.js and process it. The JavaScript file contains code that every second updates the content of the hour, minute, and second elements. With the 3 files created and linked together, your clock is fully functional. The clock example demonstrates JavaScript dynamically updating content. JavaScript can also be used for interaction. The next example demonstrates how JavaScript can be used interactively. It's a web page that plays a video. Below the video, there is a button that plays or pauses the video. The button contains a play icon. My HTML page describes the content, which is the video element and the play button element. The HTML code references a CSS file that the browser retrieves. It applies the styling to the video and button. The code in the HTML file also references a JavaScript file. The browser will retrieve the videoplayer.js file and process it. In our example, the code in the JavaScript file performs 4 actions. Firstly, it registers a listener on the button that will execute some code when the button is clicked. The second function is that when the code runs, it checks the current state of the video. The result of that check is, if the video is currently stopped, it begins playing the video and changes the button's icon to a stop icon. Or, if the video is currently playing, it stops playing the video and changes the button's icon to a play icon. Using the 3 files, you create a fully interactive video player. A summary of your functioning video player application is, when the user first sees the page, the video will be stopped by default. When they click the play button, the button will change to a stop icon and the video will begin playing. When they click the button again, it will change back to a play button and the video will stop playing. I hope those examples give you an idea of how the 3 core files link and work together. In both the clock and video examples, the HTML file referenced the CSS and the JavaScript files. The CSS file is called on to format and style your application.
You've learned that computers need IP addresses to communicate with each other. When your computer connects to a network, the Dynamic Host Configuration Protocol, or DHCP, as it is commonly known, is used to assign your computer an IP addresses. The computer communicates over user diagram protocol using the protocol with a type server called the DHCP server. The server keeps track of computers on the internet and their IP addresses. It will assign your computer IP address and respond over the protocol to let it know which IP address to use. Once your computer has an IP address, it can communicate with other computers on the internet. Domain name system protocol. I will leave my heart at the door. I will say you are before you know. So why don't we just play pretend? Didn't we scared, but promise us. Scared with nothing left. But look, don't get me wrong, I know. I wanna be cruel. Honey, can't you forgive me? So all I ask is if this is my last night with you. Hold me like a more than just a friend. Give me a memory I can use. Tell me by the hand why we do what lovers do. It matters how this ends. 'Cause what if I never love again? Easy, this is my last night.
When you're doing something online, you
Hold me like I'm more than just.
are likely to encounter web pages, websites, and web applications. But how do they differ? As a developer, how do you decide which one to create? Let's explore the main features of each one. A typical web page is one single page that consists of HTML, CSS, and JavaScript. It displays images, text, videos, and other content in the web browser. If a web page is one single page, then a website is a collection of web pages that link together under one domain name. You've likely visited many websites this week. You know when you visit your favorite encyclopedia website and the homepage has a lot of links to different articles? Clicking on one of those links brings you to an article on a new web page. And that article links to more articles on other web pages. Well, since all of these web pages exist under the same domain name, they are a website. The technical term for a link you click on is a hyperlink. This is because they link to hypertext content. Remember that HTML is hypertext, markup language. However, links themselves don't have to link to the same website. They can also link to other websites. For example, when you go to your favorite search engine and search for a phrase, the search results are a list of links to other websites. You'll explore more about hyperlinks later. By now, you should probably know the difference between a web page and a website. But what about a web application? This is where the definitions get a little more blurred. The terms website and web application are often used interchangeably. The terms website and web application are often used interchangeably. The key difference between a website and web application is the level of interactivity and dynamic content. The easy way to remember this is that a website is more informative and a web application is more interactive. Think of ordering food online. Let's say you would like to order some food and you go to your favorite site. The browser then displays a web page. You select some food from the menu and submit your order. Compare this to, for example, a company website that displays information about themselves and the services they provide. In the food ordering example, the content displayed is specific to your user account and location. The web application displays content based on the user's input and interaction. Whereas with the company website, the user simply views the content, and this content is the same for everyone who visits the website. You should now be able to distinguish between web pages, websites, and web applications you know that web pages at a particular domain make up a website, and that the key difference between websites and web applications is the level of interactivity and dynamic content.
This is I don't wanna be cruel.
If a car breaks down, you can open the hood to examine the engine and to find out what's gone wrong. If a car breaks down, you can open the hood to examine the engine and to find out what's gone wrong. As a developer, if your front end isn't working as expected, you can also open the hood to check what's going wrong. In fact, it's not just your own code that you can investigate. How about viewing other people's code? By the end of this video, you'll be able to access and make use of common web browser developer tools. Most web browsers come equipped with a set of developer tools that allow developers to inspect their HTML, CSS, and JavaScript code. Also, to trace HTTP requests to the web server, investigate performance issues, and review web page security. Let's find out more by exploring the homepage of the Little Lemon Cafe. To begin, I've just opened the Little Lemon Cafe's web page on my Chrome browser. On the homepage, I can view their menu, but I want to explore the HTML structure of this menu. To do that, I need to open the developer tools. To open the developer tools in Chrome, press the F12 key on your keyboard for PC or Command-Option-J on Mac. Alternatively, you can right-click on the web page and select Inspect. There are various tabs on the top row of developer tools that provide different functionality. In this video, I'll give you a high-level explanation of some of the most used tools, outputs JavaScript logs, and first, let's open the Console tab. This tab outputs JavaScript logs and errors from your web application. The Sources tab shows all content resolved for the current page. It includes HTML, CSS, JavaScript images, and videos. With the Network tab, you can inspect the timeline and details of HTTP requests and responses for the web page. The Performance tab shows what the web browser is doing over time. It is useful if your web application is running slow because you can pinpoint the functions that are taking the most time. The Memory tab displays the parts of your code that are consuming the most resources. Finally, let's check the most used tab, the Elements tab. You can use this tab to inspect the document's HTML elements and their properties. For example, when I hover over an element in the Elements tab, it highlights that element in the browser pane. On the right side of the panel, there are tabs for inspecting the details of the elements further. This panel shows us what CSS is applied to an element and the result of the element displayed in the browser. You will explore these details in a later lesson. For now, you just need to know that if you click on an HTML element, then the information for that element will appear in the tab. Now, I'm going to demonstrate a fun trick. If you double-click the HTML, you can edit it in the web browser. For example, you can set The web browser developer tools are a valuable part of your development toolkit to help you investigate and diagnose problems. And you now know how to access and make use of them. Great work. You are developing solutions, but you need to save some time and build faster. What if some of your build problems have already been solved for you? Well, you can use frameworks and libraries that are designed simpler, but instead you work as a carpenter. You make chairs and sell them online. As a carpenter, you don't design a new hammer for every chair you make. It makes much more sense to use an existing hammer. But of course, you are a developer. As such, it's important for you to know that to speed up development, developers use already developed frameworks and libraries in their application development. These might be open source, meaning that the source code is freely available for anyone to modify and build from. There are thousands of open source libraries and frameworks available. Or they might be proprietary, ones that are licensed or developed internally. Many developers use the terms framework and library interchangeably. So, what's the difference between them? Libraries are reusable pieces of code that can be used by your application. They are purpose-built to provide a specific functionality. To give a more technical example, you're building a small e-commerce website. When a user wants to register, they need to provide their email address. Email addresses, while easy to read, can be complicated to validate. In fact, email addresses are defined across several technical specifications. That's a lot of reading just to validate an email. Even if you do read through all the specifications, there's no point in spending hours or even days implementing their standards because you have access to so many readily available libraries to validate email addresses. It is for specific functionality, like validating an email address, that libraries are useful. A developer simply uses the library to access the functionality they require, and as a result, they can have more time to continue focusing on the development of their application. Frameworks, on the other hand, provide a structure for developers to build with. Consider this in the context of our carpenter analogy. As a carpenter, you create a lot of different chairs. Therefore, there would be a blueprint for each chair to speed up building them. You can decide the type of wood to use, but the dimensions and style of the chair are always the same. Frameworks act as a structure where the developer provides their own code that the framework interacts with. For example, there are many frameworks for developing web applications. These frameworks handle functionality that is common to all web applications, such as receiving HTTP requests and sending HTTP responses. The developer then adds their own code that implements the functionality of the web application. For instance, with the e-commerce website example, a framework would handle receiving HTTP requests. The developer would implement code that processes the request and returns a response from which the framework would send a response over HTTP. Now, let's compare how the frameworks relate to libraries. Most frameworks use many libraries. The libraries that the framework uses can be used by your application. If you wish, your application can also use other libraries. You also need to consider when to use a framework and when to use a library. Frameworks are considered opinionated, and libraries are considered unopinionated. This is defined as the degree of freedom available to the developer to choose how to code a feature. The opinionatedness will vary between frameworks, but by definition, they will always be more opinionated than a library. Frameworks, but by definition, they will always be more opinionated than a library. Frameworks define the libraries, flow, and control of an application. Whereas with libraries, those are left to the developer to decide. As with everything, there are advantages and disadvantages to both. Frameworks are a great way to reduce development time and to enforce a structure on how code is written. They have many best practices already in place and contain most of what is needed to develop an application. However, sometimes you may find that the way you need to code something doesn't fit into the structure of the framework. Other times, you may find that some of the libraries the framework uses may conflict with a library that you are required to use and cause compatibility issues. If an application is built without a framework, the developer will need to decide on the set of libraries they wish to use to achieve the functionality they must deliver. They will also need to take care that the selected libraries can work together. The upside to this is that they can replace libraries as needed. For example, if a new, better library is released, the developer can replace the usage of the old library. This is much easier than replacing a framework. Frameworks and libraries give you the opportunity to reuse existing web app functions. This can result in faster development, fewer errors, and more time for you to spend on the essential features of your application. Instead of reinventing the wheel, you can use frameworks and libraries that are designed specifically to help your web app development processes. Every day, you access information on your phone, like reading the news, purchasing goods and services, or communicating with friends over social media. But how is all this information transferred behind the scenes? Your favorite websites and apps probably use APIs. And as a web developer, you will discover that APIs are developer-friendly, easily accessible, and a very valuable and useful development tool. API is the acronym for Application Programming Interface. An API is a set of functions and procedures for creating applications that access the features or data of an operating system, application, or other service. If this still sounds a bit vague, just remember that the term API is intentionally open to many applications and use cases. As a web developer, a lot of the day-to-day job involves working with APIs. Some common APIs that web developers work with include Browser API, REST API, and Sensor-based API. Over the next few minutes, you'll explore each of these API types and review a few specific examples. To begin with, here's a brief outline of how APIs function. In software development, APIs are often the bridge between different components or systems. This earns them names like gateway or middleware. The term is used widely to represent many different tools and systems. Let's consider some examples of different API use cases. One common type of API is browser or web APIs, which are built into the browser itself. They extend the functionality of the browser by adding new services and are designed to simplify complex functions and provide easy syntax for building advanced features. A good example is the DOM API. The DOM API turns the HTML document into a tree of nodes made easy by adding which are built into the browser different tools and systems. Let's consider some examples of different API use cases. One common type of API is browser or web APIs, which are built into the browser itself. They extend the function is browser or web APIs, which are built into the browser itself. They extend the functionality of the browser by adding new services and are designed to simplify complex functions and provide easy syntax for building advanced features. A good example is the DOM API. The DOM API turns the HTML document into a tree of nodes that are represented as JavaScript objects. Another example is the geolocation API that returns coordinates of where the browser is located. There are also other APIs available for fetching data, known as Fetch API, drawing graphics or Canvas API, keeping history or History API, and client-side storage, also known as Web Storage API. Another critical type of API for web development is the RESTful or REST API. This kind of API provides data for popular web and mobile apps. These are also called web servers. Let's explore REST in a bit more detail. REST, or Representational State Transfer, is a set of principles that help build highly efficient APIs. One of the main responsibilities of these kinds of APIs is sending and receiving data to and from a centralized database. We can query our own REST API or third-party ones.
You're building your website with a team of developers. The team lead refers to APIs as gateways. This is correct use by terminology.
One last type of API that you might encounter as a web developer is a sensor-based API. This is what the Internet of Things, also known as IoT, is based on. These are actual physical sensors that are interconnected with each other. The sensors can communicate through API and track and respond to physical data. Some examples are Philips Hue smart lights and NodeBots. That's a lot of API to think about. Fortunately, for web developers, the most common data API is a RESTful API, which, as you've learned, is a web server that provides responses to requests. These API web servers are designed to provide the data backbone for a web client like a web page or mobile app. This means that these APIs must be able to accomplish things like getting data, or GET, creating data, also referred to as POST, updating data, or PUT, and deleting data, or delete. APIs use REST principles and good design practices to create discoverable interfaces. This helps us get the exact response expected. But exactly how do they work? Here's a closer description of their activity. These APIs use endpoints to specify how different resources can be accessed. The endpoint is built into the URL when accessing the API. Once the endpoint is hit, the API performs whatever server-side processing is needed to build the response. Two common forms of response are full web pages, a data form based on JavaScript called JSON. In this video, you explored some APIs, and as a web developer, you will frequently work with many different types of APIs. You will often use APIs to extend the abilities of systems or to act as a bridge between different components. Think of a group of construction workers. Every worker has a toolbox that helps them get their job done. As a developer, you'll also use many tools. One of the main tools in your toolbox is the Integrated Development Environment, or IDE. By the end of this video, you'll be able to identify an IDE and explain the benefits of using an IDE during development. An Integrated Development Environment, or IDE, is software for building applications. An IDE is just like a text editor, except instead of writing documents, you're writing code. There are many IDEs available. Some are specific to one programming language, while others support many languages in one IDE. Let's explore some common IDE features. Here I'm working within an IDE. First, let's cover syntax highlighting. To improve readability for developers, IDEs have syntax highlighting. What this means is that special keywords of the programming language are highlighted in different colors so that the developer can quickly differentiate these keywords from other text. For example, if you're writing JavaScript code without syntax highlighting, it could be harder to identify keywords from other text. With syntax highlighting, that gets much easier because the JavaScript keywords and variables are colored differently. Now, let's explore error highlighting. Just like checking spelling in a text document, IDEs can highlight mistakes you make in your programming code. For example, if I delete the equal symbol where it's needed, my IDE will highlight the error. Another feature of IDEs is autocomplete. When you're can offer other features function to demonstrate, it can also be called in the to rename it in every function. Part of
Which of the following can be done using the developer tools in your browser? Which of the following can be done using the developer tools in your browser? Which of the following can be done using the developer tools in your browser? Select all that apply. In software development, a library provides reusable piece of code that can be used by your application. In software development, an API is set a function not a component service named component. Which of the following are benefits of using an integrated development environment, such as Visual Studio Code? select all that apply.
You've reached the end of this module on web development. Over the course of this module, you've explored the basics of how the web works and familiarized yourself with key concepts in core
And we're not pick up Lance's courage. Oh, I know how long by my side. Được. Không, cậu phải chia ta. Protocol.
internet technologies. Let's recap the key skills that you gained along the way. You started the module with an overview of how the web works and explored the basics of web pages, web servers, and web browsers. In terms of web pages, you should now be able to differentiate between a website and a web page by outlining the key elements of each, outline the purpose of HTML and CSS, and provide an explanation of how they work, and identify the benefits that JavaScript provides to a web page, like interactivity and data processing. You've also explored the basics of web servers and should be able to explain how a data center provides storage and power for web servers, differentiate between the key functions of web server hardware and software, and outline how a web server handles requests through HTTP or Hypertext Transfer Protocol. And you explored the third key technology of the web, which is web browsers. Following this exploration, you should now be able to explain what a web browser is, describe how a web browser receives content from a web server and displays it for users, and outline the request-response cycle. After your study of how the web works, you investigated core internet technologies. You should now be able to explain the concept of IP addresses and how they facilitate the transfer of data across the internet, demonstrate an understanding of how HTTP functions and identify common HTTP methods, and outline how HTML, CSS, and JavaScript interact with one another to generate web pages. Differentiate between a web page, website, and web app. Identify the front end and back end of a web app, and list common web browser developer tools. And finally, you should be able to demonstrate an understanding of libraries and frameworks, along with their advantages and disadvantages. Identify an application programming interface, or API, and explain how it's utilized in application development, and explain the purpose and benefits of an IDE, or integrated development environment. Now that you have completed this module, you should be able to demonstrate your knowledge of the basic concepts of how the web works, and you've also demonstrated your understanding of core internet technologies. You've made a great start on your learning journey. Excellent work.
when two computers connect directly to each other, this form
When a team of builders begin constructing a building, one of their key tasks When a team of builders begin constructing a building, one of their key tasks is to assemble the frame. It doesn't matter what kind of building it is, it always starts with a frame of beams and rafters. Once in place, the frame guides the rest of the construction. If you compare a building with a web page, an HTML document is a lot like the frame. It's a basic structure assembled with different components such as tags and elements. In this video, you will learn about HTML documents and the difference between HTML tags and elements. To begin, let me tell you a short story. Imagine your favorite social media site. If it was just an HTML document, users would be able to scroll the page, look at pictures and read text. Would be able to scroll the page, look at pictures and read text, but they wouldn't be able to log in, like posts, or get notifications for new messages. In order to allow users to do these things, they need to be able to interact with objects on the page, such as the reaction icons or the comment button. Or, let me put it differently. An HTML document must be represented in a certain way so that JavaScript code can query and update it. To do this, we use the document object model. In this video, I will unpack what the DOM is, how it is created, and how JavaScript interacts with the DOM to make sites dynamic. When your web browser receives an HTML page, it constructs a DOM to represent it. DOM stands for Document Object Model, and it is simply a tree structure or model of the objects in your HTML file. To understand the DOM, I want you to think of a simple HTML page. Remember that an HTML document has opening and closing tags for the document and the head, and inside the head tags, you have title tags. Then you have the body, and inside the body, there might be elements such as div tags. Okay, now let me guide you through how a DOM would be generated. The DOM has a series of objects, each representing a single HTML element. At the root of the DOM is the HTML object, and it contains the head and body object. From there, the head object houses the title object, and the title object contains its text object. The body object contains the two div objects. The first div houses the heading 1 object, which again houses its text object. The second div object contains the paragraph object, which contains its text object. In summary, all the elements in the HTML file are represented as objects in the document object model. I just took you through a very simple web page. Web pages typically have hundreds of elements. Can you imagine how complex the DOM of a highly interactive modern web page is? You as a developer can use JavaScript to access and modify the DOM to make your web pages dynamic. In fact, in a later course, you will learn how to access and modify the structure of the DOM and its elements in different ways. Now that you know what the DOM is and how it is referenced, let me briefly explain common DOM and JavaScript uses. For each element, you can access the HTML attributes and content. This means you can update the existing content that is displayed in the web browser. For instance, you could write some JavaScript to update the seconds, minutes, and hours of a digital clock on a website. Or, if you develop a movie streaming website, you can write code that responds to user actions such as clicking, mouse over, scrolling, and so on. In this way, you can allow a preview of the movie to play when the user hovers the mouse over the movie's poster. Or, you can think of a login page. When users click the login button, you can disable the button so that it cannot be clicked again. The web application would bring them to a new web page or would re-enable the button if a login error occurred. You can even add DOM objects to dynamically add new HTML content to a live web page. For instance, you can add an error message to a form if the user inserts invalid data. DOM objects can also be deleted, which will remove the corresponding HTML displayed in the browser. Think of a to-do list on a website. You can remove an item from the list when the user clicks on it. Another major use of JavaScript and the DOM is to animate the HTML elements. This can be quite complex depending on the animation, but there are many libraries available that aim to simplify this. For example, when a page first loads, you can fade in the page contents. Or, when a user receives an instant message, a notification can pop up in the web browser. Many JavaScript libraries and frameworks rely on the DOM. One of these libraries is the React library. By now, you know what the DOM is, how it is constructed, and the wonderful things web developers can do with it to create modern interactive websites. Next time you use your favorite social media site, think about how the DOM is working behind the scenes to change the color of that like button. As a web developer, you should try to ensure that everyone can access and enjoy the internet. Almost like an architect that needs to design a building with ramps and rails so that it is accessible by all. You need to build a website in a certain way to improve accessibility. When the Web Accessibility Initiative, or WAI, was launched in 1997, the creator of the World Wide Web, Sir Tim Berners-Lee, said, "The power of the web is in its universality. Access by everyone, regardless of disability, is an essential aspect. Web accessibility aims to allow people with disabilities to understand, navigate, and interact with websites." A common misunderstanding is that it refers to visual disabilities, but in fact, it includes all disabilities that affect interaction with websites, such as audio and visual disabilities, cognitive and neurological disabilities, and physical and speech disabilities. The W3C Web Accessibilities Initiative develops specifications and supporting resources for accessibility. These are considered international standards for web accessibility. In fact, web accessibility is becoming a requirement in many industries. In 2016, the European Union approved the Web Accessibility Directive, which requires websites and mobile applications of public section bodies to be accessible to those with disabilities. Let's explore some examples of how accessibility is provided to those with different disabilities. People living with disabilities often use assistive technologies to aid them in browsing the web. Screen reader software can read the content of websites and everything that is happening on the device. Screen readers are used not only by blind and vision impaired users, but also by those with reading or learning difficulties. Speech recognition software can turn spoken words into computer commands or dictate inputting text. This is useful for people who may not be able to use a mouse or keyboard due to physical or neurological disabilities. Subtitles and video scripts in videos provide assistance to those with audio and visual disabilities. There are many steps that you can take to improve accessibility. It is good practice to think of accessibility from the beginning of a project. It is a lot harder to rework the project to be accessible later on. If you use the correct HTML structure and appropriate elements as a foundation, it will greatly improve accessibility. In this course, you will learn to structure your HTML properly and follow best practices to support assistive technologies. For example, having text that is not contained within proper tags, like paragraph or heading tags, makes it harder for assistive technologies to interact with the content. Similarly, using multiple line breaks to break up text and add space also presents barriers to accessibility. These are just simple examples to improve web accessibility. However, in the future, you'll probably develop very complex user interfaces, and to make them accessible may not be as straightforward as just having correct HTML. Fortunately, one of the tasks of the WAI is to define the Accessible Rich Internet Application, or ARIA specification. The ARIA specification outlines different techniques to improve accessibility for complex web apps. Now you know about different assistive technologies and that you should use the correct HTML structure and appropriate elements to improve accessibility.
What is the padding box with the following CSS rule? Which CSS which CSS property and value change the HTML element to block 11. Let's explore how to align text and HTML elements using CSS. Let's first focus on horizontal alignment. Vertical alignment is more difficult, so you'll explore that later on. Text alignment. Aligning text within an HTML element is very simple. To do this, you use the text align CSS property in the following example. The CSS rule is setting the text of all paragraph elements to be center aligned. Text align. The child element will have a width equal to đã nó hiện người ta đọc được đơ này tại vì chúng ta đâu có nhắc đọc đơ này không phải là liên minh mà một thầy. The child element will have a width equal to 50% of the parent element with the padding of 20 pixels. Note that padding 20 pixels is shorthand for setting the padding top, bottom, left, and right to 20 pixels. To visualize the spaced copies, set the border to green. Okay, marking. When using the anchor tag,
Anchor.
anchor tag, a which attribute you have here. Hyperlink reference. When adding an image to a web page, how many columns exist? How many columns exist on the following HTML table? Column, cái đi là chứ thế rồi là table row.
You've reached the end of this introductory module on HTML5 and
practice building your
He talks to the woman at the desk. Can I help you?
I want to buy a ticket to Barcelona.
Where are your parents?
Excuse me, I'm not 7 years old.
How old are you?
I'm 8 years old.
A ticket to Barcelona is $400.
Okay. Where can I go for $13?
Junior's dad, Eddie, runs to the desk.
Junior! There you are! What are you doing at the airport?
I have a math test today. I need to leave the country.
Okay, how much is the ticket?
$400.
How much are...
$800.
Right, you're great at math. Now go to school. Parents, airport, ticket, don't decline.
Are you busy on Sunday? On Sunday, we have a lot of meetings. We have a lot of meetings. We have a meeting tonight. We have a meeting tonight.
They work in a small city. They work in a small city. They work. Small city.
I teach English at a university. English. I teach English at a university. At university. Do your parents work in a bank? Do your parents work at? Do your parents work in a bank? Bank. Not bank. What do you do? Bank.
What do you do? Bank.
Do you on bank?
They work together in a bank.
They work together in a bank.
Bank.
I have an important meeting tonight.
They have
I have an important meeting tonight. Are you busy on Sunday?
Are you busy on Sunday?
Busy on Sunday.
Do they work in a small city?
Do they work?
Small. Few.
Do they? Do they? Do they work? Do they work?
Work. Do they work in a small city?
Work.
Do they work in a small city? City.
I teach English at a university. Teach English at. I teach English at a university. What do you do? Well. Do you do? What do you
they work? Do they work in a small city? 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 Kina. Kina. In a small city. Do they work in a small city? Do they work in a small city? We work together at a bank. We work together at a bank. We work together. We work together on a bank. They work in small.
Hello and welcome. Imagine you want to cook a dish you never tried before. You can try different ingredients, different cooking times, or you can just use a recipe you found on the internet. In a similar way, as a developer, you can try to build your website from scratch, or you can use code that other developers created. In this video, I'll illustrate how to include CSS and JavaScript libraries in your HTML file. I'm also going to explain what dependencies are, the purpose of a package manager and JavaScript bundlers. Let's get started. By now, you know you write code in your application and that this code interacts with APIs provided by libraries and frameworks. Since you'll be deploying your application to a web server in the end, you must include these libraries and frameworks with it. If you do not include them, your application won't be able to call the API functions it needs to execute when you run it. That is why the libraries and frameworks are often referred to as dependencies. Your application depends on them. On the front end, you do this by referencing the JavaScript or CSS files in your HTML file. One popular library you can use to develop user interfaces is the Bootstrap library. You will learn more about Bootstrap in this course, but for now, let me demonstrate how a library such as Bootstrap can be included on a web page. Start by opening your HTML file. Next, add the CSS library for Bootstrap in the head element using a link tag. The link tag includes an href attribute to link the CSS library I am including. I also included a rel attribute to specify that the link is for a style sheet. Bootstrap included a rel attribute to specify that the link is for a style sheet. Bootstrap also provides a JavaScript library that enables enhanced functionality such as drop-downs and tooltips. You'll likely need those features during development. So let me demonstrate how to add the JavaScript library to your web page. Open your previous file that already has the Bootstrap CSS. Next, add the JavaScript library for Bootstrap in the body element, using a script element. I then add an src attribute to the script element to specify the link to the library. Let me add a Bootstrap button to the page to demonstrate how easy it is. In the body, I add the button element. Then I add an attribute called type and the CSS class btn. I also add the modifier btn-primary and a description. Click this button. This will add a button using Bootstrap's primary color, blue, on the web page. This is what the rendered version of the code will look like. You can now start using the additional Bootstrap functionality. This is quite a simple example. In day-to-day development, however, it can end up being a lot more complicated. For example, what happens if your dependency also depends on other libraries and frameworks? This is known as a dependency tree. A project could have hundreds of dependencies in its tree. It will take a very long time to download, set up, and configure all of them. And how do you make sure you're using the same versions the rest of your team is using? This is where package managers come in. A package manager is a tool that automatically downloads and installs dependencies. We also refer to dependencies as packages. A package manager also provides the capability to publish your own packages. But let's not worry about that right now. For each dependency, you can specify a version of that dependency, and the package manager will download it for you. If there is a dependency tree, the package manager takes care of that for you. It will automatically download all of the dependency tree so that you can use APIs without dependency issues. The most common package manager for front-end development is the Node Package Manager, or NPM for short. You'll have an opportunity to explore the NPM later on. Now that all your dependencies are downloaded, you need to include them in your HTML file. But adding all of them into an HTML file would take forever. This is where you will use a bundling tool. The purpose of a bundler is to automatically combine them into a single file. If your bundle is significantly large, many bundlers can split your dependencies into multiple bundles. There are many bundlers available, such as Gulp and Webpack. You'll explore bundling in more depth later on. You now know how to include CSS and Java.
As a deploy your application to a web server, you will use the vendor tool select correct.
JavaScript libraries in your HTML file. You also know what a dependency is, what the purpose of a package manager is, and what JavaScript bundlers are. Have you ever wondered how the size of a website can so easily adjust between different devices like laptops and mobile phones? Well, the answer is responsive design. Responsive design means that a web page can automatically stretch or shrink depending on the screen it's displayed on. In the world of web development, you use responsive design every day. Let me share how it works. In this video, you will be able to explain how responsive design is used to provide the best user experience based on the device that the website is viewed on, describe CSS media queries and screen resolutions, classify fluid images, and differentiate between fixed and fluid grids. Phone, tablet, and computer screens, including the one you're probably using now, are made up of thousands of tiny lights called pixels. The resolution of your screen refers to the number of pixels it contains, most often expressed as the number of horizontal pixels multiplied by the number of vertical pixels. For example, a common computer screen resolution is 1920 pixels in width and 1080 pixels in height. Thanks to responsive design, websites can be correctly displayed on any of your devices. However, today we have many different screens with different resolutions, which is why responsive design is so important. And it is complicated by new high-resolution screens like the one found on your mobile phone. These screens group multiple physical pixels into one logical pixel to display smoother images and text. These are often used in your favorite smartphones to give more high-definition visuals, like making text, images, and rounded edges appear smoother and making the individual pixels less visible. Given all the possibilities and complicating factors, it would be challenging to develop websites that appear correctly on all edges appear smoother and making the individual pixels less visible. Given all the possibilities and complicating factors, it would be challenging to develop websites that appear correctly on all kinds of devices if it wasn't for responsive design. Responsive design is a set of 3 practices that allows a website to automatically change its visuals. In other words, to respond based on the device it is displayed for, it would be dual pixels, multiple physical pixels into one logical pixel to display smoother images and text. These are often used in your favorite smartphones to give more high-definition visuals, like making text, images, and rounded edges appear smoother and making the individual pixels less visible. Given all the possibilities and complicating factors, it would be challenging to develop websites that appear correctly on all kinds of devices if it wasn't for responsive design. Responsive design is a set of 3 practices that allows a website to automatically change its visuals. In other words, to respond based on the device it is displayed on. It is the combination of 3 techniques: flexible grids, fluid images, and media queries. Firstly, flexible grids, fluid images, and media queries. Firstly, flexible grids are made up of columns, gutters, and margins. The space between the columns is called the gutter, and the spaces between the content and the left and right edges of the screen are called margins. Instead of defining website element sizes based on pixels, flexible grids are defined in percentage values, allowing them to adjust depending on screen size. Next, you have fluid images. By setting the CSS max width property of images to 100%, the images will scale down smaller if their containing column becomes narrower than the image's size, but never grow larger. This enables an image to scale down to fit in a flexibly sized column rather than overflow it, but not grow larger and become pixelated if the column becomes wider than the image. Finally, there are media queries that are part of CSS. They allow developers to query the display size, orientation, and aspect ratio to conditionally apply CSS rules. For example, the column becomes rather larger. This enables an image to scale down to fit in a flexibly sized column rather than overflow it, but not grow larger and become pixelated if the column becomes wider than the image. Finally, there are media queries that are part of CSS. They allow developers to query the display size, orientation, and aspect ratio to conditionally apply CSS rules. For example, if you wanted your website background to appear blue on a screen size less than or equal to 700 pixels, like on a mobile phone, you could use a media rule to set the background depending on the size of the screen. Remember that I said responsive design is the combination of flexible grids, fluid images, and media queries? When these elements are used together, you build a website that will automatically adjust its layout based on the device, thus delivering a responsive grid. In responsive design, the pixel value specified is delivering a responsive grid. In responsive design, the pixel value specified is often referred to as the breakpoint. A breakpoint is the point at which a website's content and layout will adapt to provide the best possible user experience. A breakpoint can function in different ways across 3 different grids: a fixed grid, fluid or full-width grids, and lastly, hybrid grids. Let's explore each of these now. Firstly, a fixed grid has fixed width columns and flexible margins. The fixed grid has a fixed content width that doesn't change in a specific breakpoint range, while the flexible margins occupy the remaining space on screen. Then, we have fluid or full width grids with fluid width columns and fixed gutters and side margins. The fluid grid has a flexible content width that goes edge to edge as per the screen size. In a fluid grid, columns either grow or shrink to adapt to the available space. And finally, there are hybrid grids that have both fluid width and fixed width components. Many responsive design frameworks provide multiple CSS rules based on different device sizes to provide the best visual experience.
There are myriad queries that are part of CSS version 3 specification. What do they allow developers to query in order to conditionally apply CSS rules? Choose all that apply.
Now you know the importance of responsive design. In the next few videos, you are going to learn more about Bootstrap, the world's most popular framework for building responsive mobile-first sites. Part of each other. Bootstrap is a collection of pre-written code chunks in CSS and JavaScript that allows you to create websites more quickly than if you had to create every bit of code from scratch. Building websites from scratch every time would be quite time-consuming. This is where Bootstrap comes in. In this video, you will learn how to create a simple Bootstrap web page. To do that, I am using the file with the Bootstrap libraries I have created. So let's begin by setting up the layout. The first element I need to add when setting up a Bootstrap website is the container element. I need it before I can use the Bootstrap grid system. So I add an HTML div element and apply the container CSS class provided by Bootstrap. Next, I add a row for the content. Similar to what I had in the container element, a row is an HTML div element which uses the row CSS class provided by Bootstrap. I add the row CSS class below the container CSS class. Under this row, I want to add 2 columns, one for the menu items and one for the prices. So I add 2 div elements with the col CSS class, one for each column. Col is short for column. Now, I want to name the columns. I do this by adding heading tags in each div. Within the first column div element, I add a heading 1 tag or H1 tag, and I type the name of column 1, our menu. In the second column div element, I type prices in an H2 tag. Under the our menu column, I will add the name of each dish, the ingredients used, and an image. First, I add a heading 2 tag below the our menu H1 tag, and inside it, I add the name of the dish, falafel. Under the falafel H2 tag, I add a paragraph or P tag. Inside this tag, I list the ingredients, chickpea, herbs, and spices. Now to add an image of our falafel. I add the IMG or image tag, and inside it, I add the SRC or source attribute as it is known. In the source attribute, I enter the name of the image file I want to link to. I type falafel.jpg as the source for the image. I now add a CSS class called img-fluid or img fluid, as most developers call it. Instead of having to manually set the image size, the img-fluid class will ensure my image scales to its parent column's width. Next, let's add another dish. I add another heading 2 or H2 tag, and inside it, I add the name of the dish, pasta salad. Under pasta salad H2 tag, I add a paragraph or P tag and list the ingredient and watch tag. I enter the name as the source for this image. Now, I save the file by pressing the key. Next, I preview the web page in live preview. The dishes are now displayed in columns and the images are sized correctly. Now, let's add the price table. So, under the price column, I add an HTML table tag and apply the Bootstrap CSS class for tables. Inside the HTML table tag, I add 2 table row tags or TR tags. This will create a row for each of the dishes. Then, I need to add table data tags or TD tags. Table data tags define the contents of table cells, so I will need to add 2 of those inside each row, one for the dish name and one for its price. In the first row, I add falafel to the first TD tag, and in the second TD tag, I add the price. Let's say $12. I do the same with the second row. I type pasta salad inside the first TD tag, and the price of $10 in the second TD tag. I save the file again by pressing Ctrl and S, or if you are on a Mac, Command and S. Next, I preview the page in live preview. The table structure now displays using the Bootstrap table style. You have now learned how to make a simple web page using Bootstrap. As a developer, you are tasked to design a website for the Little Lemon restaurant. One of the main requirements is that the website easily adapts to different devices, platforms, and screen sizes. Does this mean that you'll have to redesign the website for each device? No, relax. You do not have to redesign your website for each device. In this video, I'll introduce you to Bootstrap CSS class infixes and modifiers, and you will learn how you can use them to save you time. Let's get started. Bootstrap has quite a large CSS library, built by Bootstrap's developers using thousands of use cases. How it achieves this is through CSS classes and their variations through infixes and modifiers. It is important that you, as a developer, understand infixes and modifiers, and you will explore each of these terms. you will use class infixes for responsive breakpoints in the Bootstrap grid system. Let's go ahead and cover how infixes are used. You already know that breakpoints are the triggers in Bootstrap for how your layout changes across device or viewpoint sizes. Here are the responsive breakpoints available in Bootstrap and how we use them. Note that each has a specific name. Extra small is for screens less than 576 pixels wide. Small is for screens greater than or equal to 576 pixels wide. In Bootstrap CSS rules, this is abbreviated as SM. Medium is for screens greater than or equal to 768 pixels wide. In Bootstrap CSS rules, this is abbreviated as MD. Large is for screens greater than or equal to 992 pixels wide. In Bootstrap CSS rules, this is abbreviated as LG. Extra large is for screens greater than or equal to 1200 pixels wide. In Bootstrap CSS rules, this is abbreviated as XL. Extra large is for screens greater than or equal to 1400 pixels wide. In Bootstrap CSS rules, this is abbreviated as XXL. Did you notice that there is no class infix or dimension for extra small on the list? This is because extra small is the default breakpoint in Bootstrap CSS rules, as Bootstrap is mobile first. We use the abbreviations for these breakpoints as infixes in the CSS rules for the grid system. This basically means you have to insert the abbreviation into the CSS class name. I will show you how to use this shortly. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. Let's now learn how to use modifiers through an example that uses an alert element. I can have an HTML file where I set an alert primary CSS class that is applied to the element. Alert primary displays the alert using Bootstrap's primary color, which is blue. The dash primary part of the class is the modifier. If you want to change this to red, for example, for an error message, you will use the danger modifier. Here is a list of modifiers available in Bootstrap: primary, secondary, success, info, warning, danger, light, dark. Alerts are often used to show information that needs immediate attention from users, such as warnings, errors, or confirmation messages. Bootstrap provides an easy way to create predefined alert messages, and it also has different types of alerts. The difference between the alerts is just the color used to display the predefined alert message. For example, the primary alert displays the alert using Bootstrap's primary color, which is blue. On the other hand, the alert using Bootstrap's primary color. Which is blue. On the other hand, the danger alert displays the alert in red. Now, let's turn our attention to how this works in code.
Now, as a web developer, you will use modifier to indicate the breakpoint, breakpoint in Bootstrap.
In this HTML file, I have a 6-column CSS class applied to a div element. In this example, I want to change this rule for large screens. To do this, I infix LG into the col CSS class by adding col-LG-6. Bootstrap components provide a pre-built set of reusable UI styles and elements for your web applications. For example, I can add an alert component. I do this by adding an alert CSS class, followed by the contextual class, alert-primary. Now I have to identify the function of the alert. To do this, I add a role CSS class directly after the contextual class, alert-primary, and type alert. On the next line, I type the name that must be displayed on the alert, a message. Alerts are useful for displaying information, warnings, or error messages to users. The contextual class, alert-primary, will display the alert using Bootstrap's primary color, which is blue. The primary part of the class is the modifier. If I want to change the color to red, for example, for an error message, I will use the danger modifier. To change the color to red, I simply replace the modifier primary with danger. Now you have learned about CSS class infixes and modifiers and how you can use them to save you time. As you have previously learned, building a website using responsive design requires a responsive grid and responsive breakpoints. Bootstrap provides both of these as part of its library. The Bootstrap grid system helps us to create web page layouts through a series of rows and columns that house our content. For the grid, Bootstrap uses a 12-column grid system that can be fluid or fixed. The Bootstrap's grid system always has a container that can be fluid or fixed. The Bootstrap's grid system always has a container, rows, and columns. Bootstrap's grid system always has a container, rows, and columns. The container is the root element of your grid. Bootstrap's grid system always starts with the container. The container contains paths and aligns your content. Its width is determined based on the current responsive breakpoint. You can add rows, and inside each row, you can add columns. Let me demonstrate how we put this all together by using Little Lemon's website as an example. Alright, I have opened my joesburgerindex.html file. In this web page, I have added 2 columns to my row. Bootstrap is smart and will set the 2 columns to span 6 column spaces. If I want to control how many spaces a column uses, I can suffix a number. Let's shrink the price column to 4 spaces and expand the menu column to 8 spaces. To do this, I add the suffix -4 to the col CSS class above the prices heading. I also add the suffix -8 to the col CSS class above our menu heading. But here's the amazing part of Bootstrap. I can configure my content to use different layouts based on the device using the breakpoint-specific CSS rules. Let's have the content stack on top of each other on mobile devices and have them display side by side on desktop devices. Since columns will wrap to new rows, if we exceed the 12-column space, we can use this to stack content. For mobile devices, I'll set the columns to use 12 spaces, each by adding -12 as a suffix to the col rule for both columns. Then for desktop, I'll set them to 6 columns each by using a col-LG rule and adding the column sizes -6 as a suffix. I will save the file by pressing Ctrl and S or Command S on a Mac and open it on my web browser. Notice that now the columns are side by side. Next, I open my web developer tools by pressing the F12 key. In the top left corner, there is a mobile phone tablet button. Clicking on this button enables the device mode. This allows me to simulate different devices. I select to view my website on a mobile phone device. Amazing. My content has stacked vertically on mobile. Bootstrap has ensured our website will work on a mobile phone thanks to its CSS rules and grid system. This will save a lot of development time by not needing to develop different content layouts per device. Bootstrap's grid system is very powerful and suitable for most development needs.
Ông đi viết rồi. Ta là sợ dơ bên.
Bootstrap includes a pre-made set of UI elements and styles to help you build your website. They range from alert messages to navigation menus. These are called Bootstrap components. In this video, you will learn how to use Bootstrap components. Little Lemon have added a new fried calamari dish to their menu, and they want to add it to their website. They also want to update their website to use Bootstrap components. First, let's add the new dish. To do this, in the menu column, I add a new H2 tag, and inside it, I add the name of the dish, fried calamari. Then I add a paragraph tag. Inside this tag, I list the ingredients: squid, buttermilk. Now, I want to add an image of the fried calamari. So, I use an image tag with its source attribute and the image file name calamari.jpg. And I add image-fluid class to ensure the image scales to its parent column's width. Bootstrap comes with a badge component that I can use to highlight that the dish is new. Let's add that now. Next to fried calamari inside the H2 element, I add a span element and assign it a CSS class of badge. Now I can set the background color of my badge by adding another class, bg-primary. The contextual class bg-primary will display the badge using Bootstrap's primary color, which is blue. Inside the span, I add the text new. Next, I'm going to improve my visuals by using the card component for each dish. With card elements, I can style and accommodate different types of content like title, subtitle, body copy, and images. For the cards, let's have them stack on mobile devices and tile side by side on desktop. To do this, I add a row below the R menu H1 tag. I then add a div element for each dish of the 3 dishes. For each div, I apply the col-12 class for mobile devices and col-LG-6 class for desktop devices. Inside each div element, I add another div element that uses the card CSS class by adding one and copying and pasting it inside the other divs. I then move the code with the image tag of each dish to the card class. Instead of using img-fluid, I change each image to card-img-top. This will improve its visual style within the card. I then add another div for each dish and give it the card-body class. This will contain the text content of the card. I then move the header and paragraph of each dish into these card body elements. Again, to improve the visual style, I add a card-title CSS class to the header of each dish. In the paragraph element, I add a card-text CSS class for each description. This will contain the dish ingredients. Our menu has a much better layout now. Finally, let's update the prices. Under the price column, I add a table row or TR tag for the new dish. Then I add 2 TD tags. TD stands for table data, but from now on, I will just refer to it as TD. In the first row, I type fried calamari in the first TD tag, and in the second TD tag, I type the price $12. Then I add an alert to inform our customers about the new dish so they can try it out. To do this, I add a div element with the alert CSS class. I add the alert-info CSS class to change the alert to blue. Now I identify the function of the alert by adding a role attribute directly after the contextual class alert info and type alert. On the next line, I type the text that must be displayed on the alert. Try our new fried calamari. The website has a much better layout now. Hopefully, Little Lemon will have a lot more orders now. There are many components available on Bootstrap. Maybe there are some more you can use to improve your website.
Perry cái đó thì quả gì đó. Menu người gặp ngu đấy. Anh chỉ sử dụng một breakpoint thôi. Nếu như làm cái này thì sao anh Sơn cái nào đang đẹp không? Ok, giảm xuống rồi. Thì sơ ví dụ là thành 3 xong đẹp không?
sao nó lại đậm lại đậm đậm lại.
Hey guys, so from the content of those items. Now the notice is something. All right, it's time to put all of our knowledge into action by building a project together. And we're going to use everything we learned about Flexbox to build a pricing table. You've probably seen pricing table out on the internet before. It's usually 3 categories, small, medium, large, and it shows the customers which features they'll get based on which tier they're going to subscribe to. This is pretty much what we're going to build, although a little bit simplified. And the great thing about our version, because we now know about Flexbox, is we can make the width of each of these pricing cards change dynamically based on the width that's available. And we can also make it responsive in the way that when the window goes below a certain size, it actually stacks these vertically rather than having them horizontally. You should have enough knowledge now to be able to complete this project. Go ahead and download the starting files for our pricing table project, extract it, and open it up inside VS Code. Now, once you're here, I want you to go ahead and look inside the index.html and show it in preview. You can see that we've got all of the HTML for you, all of the text. So this is what it should. Have a think about how you might do this, how you might apply or thinking you can get and give this as long as of this flexible container to full height, so 100 vertical height, then it's going to make everything centered vertically and horizontally. This is a really easy, almost cheats way of centering anything vertically and horizontally. You might know this, you might not, but using just normal HTML, normal CSS without Flexbox or Grid or one of the other frameworks is actually not that simple to set something to the middle of the screen. So this is an incredibly easy way of achieving that. And I hope by this point you understand why it's able to do that. The next thing we're going to do is to set our pricing plan. Our pricing plan corresponds to each of the items in our container. And what I've done is I've set the flex to 1 so that they are equal in width, and that they are allowed to grow and shrink. What I've done is I've set the flex to 1 so that they are equal in width and that they are allowed to grow and shrink. I've set the maximum width to 400, and this is probably a little bit easier to see on the full width screen. So that means that they don't go all the way. And by setting that maximum width, basically I'm saying each of these cards should limit themselves to that 400 pixel size so that they don't take up the full width, and then our centering kind of becomes moot because it's taking up the full width. And I think this just looks a little bit better in my opinion. And that's achieved using the max width. Now I've added a little bit of padding inside each of these boxes just so that they're not right up to the edge on all the sides, and I've added a sort of grey background colour to differentiate it from the background. I've given it a border radius of 5 pixels, which just makes our pretty much all just for styling. Let's go ahead and talk through each of them. The plan title I've made super large, so I increased the font size. This is all personal preference. It depends on your eye. Whatever you think is right is right. And then I've set the plan price to an even and features. And this one you might remember from previous lessons, you might not, you might have to Google for this, but essentially what it does is it gets rid of those bullet points. Because we've got a unordered list here, and list items by default have the bullet margin to get them all closer to each other, and finally added edges, none. But this combines a lot of the things that we learned previously, which is the use of a media query. I said that when the width of the screen is under 1250 pixels, I'm going to target the pricing container, which remember is our flex box container. And instead of having the flex direction be a row by default, I'm going to change it to have a flex direction of column. And what that does is when this gets under 1250 pixels, then it goes into a vertical flex box, which is really nice. It makes more use of the space And I've set that height to 100% because remember previously we had the height set to 100 viewport height, which means the height of our container is going to try and be as high as our viewport, which is only the space that we have here. Now, because we have more content than viewport height, it's actually better to set it to 100% so that it's not limited. And I'll show you what happens if I don't have this. You'll see that it's actually not quite right. When you scroll to top and the bottom, it actually cuts off a bunch of stuff. That's the one final sort of modification that I've got. I hope you have here. Now, because we have more content than viewport height, it's actually better to set it to
chưa dốc á, nó sẽ không tải được cái 11 này thì cái này đấy nhá, nó không vừa cái viewport ở đây ngay cái này cái hai chấm cái nó khá lớn thì nó không vừa cái viewport. Yes. Don't be.
a 100% so that it's not limited. And I'll show you what happened with the instead of now the final thing, which is quite interesting, and I don't know if this is something that you actually realized you could do, but this combines a lot of the things that we learned previously, which is the use of a media query. I said that when the width of the screen is under 1250 pixels, I'm going to target the pricing container, which remember is our Flexbox container. Flex direction be a row by default. I'm going to change it to have a flex direction of column. And what that does is when this gets under 1250 pixels, then it goes into a vertical flexbox, which is really nice. It makes more use of the space. And I've set that height to 100% because remember previously we had the height set to 100 viewport height, which means the height of our container is going to try and be as high as our viewport, which is only the space that we have here. Now, because we have more content than viewport height, it's actually better to set it to 100% so that it's not limited. And I'll show you what happens if I don't have this. You'll see that it's actually not quite right. When you scroll to top and the bottom, it actually cuts off a bunch of stuff. That
Hey.
The one final sort of modification that I've got. I hope you managed to get somewhere close to this. And if not, don't worry. Be sure to review some of the previous content, like the lesson on media queries or the lesson on Flexbox sizing, and just make sure that you understand at least all of the code in the solution code and you understand what's going on. It doesn't matter if you didn't manage to style it exactly the same. You know, a lot of this stuff is kind of personal preference, and maybe you've made something that's even better than what I've got here. If you have, be sure to share a screenshot in the Q&A section. I would love to see what you guys have created. That's all from me for this section, and I'll see you in the next section. Hey, well done for completing yet another module. You're really putting a lot of these belts on, you know? Like at the very beginning, you were like a white belt when you first completed your first module, when you built the first things, when you built your first app. And now you're kind of getting on like towards the blue purplish sort of belts now. So I wanted to talk about, another sort of thing that helps with habit building. And it's this idea of creating a cue for your habit. So if your habit is, say, I don't know, that you wanted to create. So if the habit that you wanted to create was, say, I don't know, do 50 press-ups every day, or go to the gym every day, or, in our case, learning to code every day, then it really helps when you have a cue that you tag your habit onto. So what I mean by that, let's say that you already have a habit, right? You probably have loads of them. For me, it could be something like brushing my teeth in the mornings. So when I've tagged on this new habit I'm trying to form, like at the end of my existing habit, it makes it that much easier to do that thing that I want to do. So for example, I had a habit that I was trying to form, which is to meditate for 20 minutes every morning. And I never really managed to get around to doing it. There was always something in the way. Until I started saying, you know what? Every single time, every morning, after I brush my teeth, I am just gonna go and sit down and meditate for 20 minutes. Nothing else. And once I started doing that, it was like as if brushing my teeth was now this trigger or this cue for this other habit. And because already I brush my teeth every day, I hope you do too, then that habit kind of like just allows the next habit to build a little bit easier. So try this out. See if you already have a habit, and then try to do just half an hour of coding or an hour of coding afterwards, and see if that helps you get into the groove a little bit easier. And let me know your results. But most importantly, you've heard me say it, you're gonna hear me say it again, keep going, keep going. I'm here for you, cheering you on. And I think you're great. I think you're doing fantastic. So keep going.
Thank you.
Easy. This is my last night with you. Hold me like come on and just a friend.
Okay. And of course, if you remember in the POM XML, I should have the dependency to the context. So I go here and I take the dependencies and I put it here.
I wish I could have said goodbye. I would have said what I wanted to, maybe even cry for you. If I knew that it'd be the last time, I would have broke my heart in two, trying to save a part of you. Don't wanna feel another touch. Don't wanna start another fire. Don't wanna know another kiss. No other name falling on my lips. Don't wanna give my heart away.
Don't wanna feel another touch. Don't wanna start another fire.